Nuke has always been built around a single shot workflow where typically a Nuke script corresponds to a single shot in production. This means the script operates within a single context. Think of the last project you've worked on. Typically, you would be using a script per shot. But productions do grow in both scale and complexity, and the need for smarter workflows has become more pressing. Studios and artists have been pushing the boundaries of what's possible, finding ways to work faster, more reliably, while maintaining consistency. To address this, we're introducing graph scope variables, the foundation of Nuke's new native multi-shot compositing workflow. These variables allow you to define, store, and access data from multiple contexts or scopes, and you can do this all within a single Nuke script. You can define scopes in multiple ways and easily switch between them based on the available variables. By consolidating scripts, eliminating duplication, and creating efficient templates, you can work at scale without sacrificing speed or quality. Think of it this way. Instead of managing 5 separate scripts for 5 shots, you can combine them into one fully optimized and flexible workflow. MultiShot opens up new possibilities for templating, indexing, and controlling variables so you can focus on finalizing shots with precision and consistency across your projects. Let's look at the components that make up the multi-shot workflow. There's the Variables tab in the Project settings. The Variables tab is the central hub for managing the data that drives a multi-shot workflow. All variables created will be stored here. The Variables panel. This panel allows you to promote the variables that might be most relevant to the artist. This quick access eliminates the need to jump back and forth into the Project Settings Variables tab whenever you want to adjust something. The Variables Switch node. The Variable Switch node allows you to switch between different shots or scopes using variables. It works similarly to the standard switch node, but also supports split and join workflows based on the variables defined for your multi-shot setup. You can select which variable to use from a drop-down, pulling directly from the variable panels in the project setting. Variable Group node. The Variable Group node provides a way to create or override variables or scopes directly in the node graph. Each time you create a new variable group, a corresponding item appears in the Variable tab located in your project settings. The live group is now variable enabled, allowing local variables within a live group. Once you publish, these variables are stored in the live group's Nuke script, and any instances using that script will load them as local variables. This makes it simpler to share and swap assets while retaining shot-specific data. Group View. The Group View feature lets you see inside group nodes from the main node graph. There's no need to jump into a separate tab. Just attach viewers, add or remove nodes, and edit as you normally would all in one place. Then there's the Link node. The Link node is a versatile alternative to clones. It creates a linked copy of nodes, keeping updates synced between the original and linked versions while allowing certain knobs to be overwritten. Clear UI indications show which knobs are overridden, and a link arrow indicates the relationship between the original node and its linked copies. Command line rendering with the graph scope variables. The command line interface now supports graph scope variables, making it easy to specify the correct shot context when rendering a script. This is especially useful for handling multiple shots at scale, ensuring each render operates with the proper settings. Combined, these tools and features provide a flexible, scalable approach to multi-shot compositing. This allows you to consolidate scripts, minimize repetition, and keep your workflow lean, even in the face of demanding production requirements. The Variables tab in your project settings is the starting point for setting up data that spans across multiple shots or scopes. Let's get started. Now, first thing we're going to do is open up the project settings and find the Variables tab. This is where you'll define and manage all of your project level variables. So we can go ahead and create a variable. Now when we do that, it's set to string type by default with an option to convert it to list if we need a drop-down style selection. So let's go ahead and create an example called show, and we're going to set its value to We Hunt Giants. This is a basic example of a string variable that you can reference across your script. Now we're going to define some additional variables. We're going to add the show root, and this is the path of where our project folder lives on disk. The plate root We'll use this to store a portion of the path dedicated to plates. Now, in this case, I just need to append directory names onto show root because I've already defined the top level path, so I'll just give the subpath. CG root, similar to the plate root, but if it's for CG assets, if applicable. The resolution, so this is handy for storing a default resolution. Frames per second. We're going to define what we're working on through a scope. So scope and is a sequence. The name of the sequence. Next, I'm going to add shot. So this time I want a list for the strings. I'm going to add the number of shots. In this case, I'll add 3. And now we can see that we have a drop down to choose from. These variables form a standard set that can be used in any of my projects. I want to make sure that there's consistency as well as reduce repetitive setup. Now, variable sets act as a simple grouping mechanism. For example, you could create a set for plate-related variables. So we'll create a new variable set and give it the name of the plate. Now, inside of here, we can add any additional variables that we find are relevant to the plate, like, for instance, the plate name on disk, frame start, frame end, and let's define its scope. In this case, it's a shot. So we can continue to go on with any other variables that we find useful. So this way we're grouping the variables and we can keep them organized, especially when working with multiple shots in a single script. Now, after defining several variables and sets, you'll see them neatly organized in the Variables tab with labeled group and values. This will help us quickly understand our project's overall structure. Now, while you can add variables manually, you can also script or automate the creation of these entries. This is especially useful if you regularly work on large-scale productions where standard variables and sets are needed across multiple projects. By automating, you save time and maintain consistency whenever you start a new job. So by the end of this process, you'll have a clear layout of your multi-shot project data, all housed in the Variables tab. Once these fundamentals are in place, you're set to reference and update them throughout your Nuke script, and this really lays the groundwork for a more efficient, robust, multi-shot workflow. The variable switch node enables you to switch between different scopes or contexts based on the variables defined in your script. In this demonstration, we'll connect 3 image inputs to illustrate how the node can quickly route your workflow based on variable values. So let's begin by adding 3 image sources. So this could be plates, CG passes, or any other elements that you want to switch between. Next, we're going to create a variable switch node connected to the inputs. Now, in the variable switch properties, we want to select the variable that we want to use for switching. We're now going to define the variable values. For this, we're going to enter info into the pattern fields. If you remember, we already defined the shot names when we created the shot variable, so we want to make sure it matches. Now, we can always edit the list or the patterns if we make mistakes. Now, you want to pay attention to which input number your object is plugged into, as it will correspond to the pattern input number in the properties. So you might need to rearrange if you have a specific pattern you're trying to follow. When you change the variable value, the variable switch node automatically switches to the matching input. We can see the output changes in real time when we toggle a variable. This allows you to maintain a single consolidated script for multiple shots or tasks, or anything really, minimizing the need for separate setups. Let's look at a split and join workflow. Let's say we wanted to add a grade node and only have it affect one of the shots. Well, let's set up the grade and then create a variable switch. So we want shot 2 and 4 to not get the grade while shot 6 receives it. Let's pick the variable we want this switch to talk to, which is shot. We can then add multiple entries into the pattern for input 0. In this case, 2 and 4 for shot 2 and 4, separated by a space. We then want shot 6 to receive the grade. So we have now split and joined our node tree using the variable switch, and we're getting the result that we're after. So by referencing variables in the variable switch node, you gain a more flexible workflow that scales easily to multiple inputs and shot contexts. And you do this all within one script. The Variables panel is an efficient way to interact with variables you set up in the Variables tab without needing to navigate back to the project settings repeatedly. provides quick access to key variables, and allows you to customize how they're presented for easier workflows. Variables that you mark as visible in the Variables tab will appear in the Variables panel. This allows you to focus only on the variables most relevant to your workflow. The Variables panel is highly flexible. You can rearrange variables or insert separators or text to create a layout that's both intuitive and tailored to your needs. Additionally, you can even use HTML to edit the style and layout similar to other areas of Nuke, if you want to add more flair or custom formatting. In the Variables tab, you can use the Edit function to customize the label and tooltip for any of the variables. This is especially useful for providing additional context or instructions for variables displayed in the Variables panel. By combining quick access, customization options, and a clean interface, the Variables panel keeps your workflow efficient and organized, letting you focus on creative tasks instead of hunting for settings. A variable group allows us to group and then create overrides to variables, as well as create new variables, all from within the node's properties. I've prepped a new root variable called grade with a list of entries called blue, yellow, and green. I also have 3 grades that correspond to those colors, and a variable switch that is talking to the grade variable. It also has the matching values in the pattern. Now I'm going to grab everything and make a variable group. First, notice that you have all the project variables accessible within the group's properties. Also, we can see that we have the variable group we just created listed, and if we look back into the Variables tab in the project settings, we can also see this group. Now, first off, we'll make an override. Let's select the grade variable that we created and change the value. Now, notice when we do this, we get a yellow icon indicating that this variable has been overridden. If we also look at the Variables tab, we can see that the root variable is set to blue, but we have an override on the variable group set to yellow. So we've created a local override that is only affecting what's inside this group. If we have 10, 20, 30, 40, 50 other switches talking to this grade variable, those will remain with the blue value, but this one is now set to yellow. You can also create new variables specific to that variable group. This makes it straightforward to keep context-specific variables where they belong. And in our Variables tab in the project settings, we see things are nicely nested under the variable group. For more complex scenarios, you can create another variable group within the first one to form a nested structure. Each nested group can override and define its own variables independently. This approach is particularly helpful when multiple layers of context or multiple shots require distinct variable sets. So let's look at another demonstration. You might have a variable group called sequence1, and this contains variables for sequence-specific data. Now, within this group, there are more groups that will house the shots that we'll be working on in the sequence. This gives us levels to work with, and at each level, we can create or override variables that will only affect the corresponding group. In this scenario, we've bundled together several shots under one broader context. Each group has its own relevant variables while still referencing any global variables you have set up initially. This layered approach ensures that you can maintain a clean structure for all the variables. This is valuable in scenarios where you have to manage shot level and sequence level data all in one cohesive workflow. All right, let's have a quick recap of what LiveGroups are inside of Nuke. A live group in Nuke is essentially a dynamic version of a group node that references an external .nk file. So this approach allows you to reuse common setups across multiple scripts. You can update the livegroup.nk file so every instance referencing it can receive those changes automatically. It allows you to maintain a more flexible, collaborative environment by separating critical elements like matte painting, look dev nodes, roto, or general effects setup into shared, updatable templates. It's also a great alternative to a gizmo because it can easily be updated as the tool evolves and everyone will receive the changes. Live groups are now variable enabled, taking this concept further by allowing each live group to define and store local variables. When you publish a live group, these variables are embedded into the livegroup.nk file. Any instance of that same live group will be able to load the local variables, ensuring each shot or asset can use specific data while still referencing a shared template. So let's say we're working on a matte painting for a shot that another artist is going to incorporate into their comp. We're going to group this as a live group. Now on the properties, we can define any local variables we might want. Maybe it's the shot name, resolution, time of day, and so on. We can publish our live group. When another artist calls in this live group, they will not only receive all the nodes inside, but also the variables that were added to the properties. And from here, we can also define or override the variables matching the same functionality as the node group. We could even store different templates in the live group with corresponding variables that will switch the path to change the template style. And then from here, we can reload and then update. So by integrating variables within live groups, the GSV live group creates a powerful, scalable system for managing content that frequently changes or needs to be shared among multiple shots. This approach helps maintain consistency and speeds up iteration, allowing artists to focus on creative work instead of setting up repetitive tasks. The Group View feature allows you to see inside group nodes directly from the main node graph. This saves you from jumping in and out of separate tabs when you need to inspect or modify what's inside a group. By default, Group View can pop up on one side of the node graph. You can configure which side the internal view appears on, which is especially helpful when building or using templates. Adjusting its location keeps your layout tidy and ensures crucial nodes remain visible. It also allows for in-place editing, so you can attach viewers, add or remove nodes, and make any necessary changes without leaving the main node graph. You can also streamline your templating, so when you're setting up or refining templates, Group View makes it easier to see and adjust the internal workings of a group node on the spot without juggling different windows. Aside from the plus button, you can also trigger the Group View from the Show Group View toggle in the properties, or disable it entirely using the Disable Group View toggle. By giving you direct configurable access to a group's internal structure, Group View keeps your workflow streamlined and more intuitive, particularly when dealing with complex or nested setups. The linked node is a more robust alternative to clones or expression linking, particularly for setups where you need multiple references to the same node. Unlike expression linking, the linked node doesn't rely on expressions to synchronize parameters. This design helps maintain stability and can improve performance when you're working with large or complex scripts. Cloned nodes can become cumbersome when less reliable when many clones are in play. Linked nodes avoid this complexity by maintaining a direct link to the original node while still allowing overrides on specific knobs as needed. You can toggle overrides with a clear indication of which knob is being affected. Because linked nodes don't use expressions to stay in sync, there's less overhead, leading to a smoother experience when updating or rendering multiple linked nodes across your script. Suppose you have a color correct node that's used for a specific grade across multiple shots. Rather than repeatedly cloning it, you can create a link node that references the original color correct node. You can add any changes to the original that will automatically propagate to all the link copies. And if you need one shot to deviate slightly, you can just override the relevant knobs without losing the connection to the base node. By leveraging linked nodes instead of clones, you get a scalable, efficient approach to sharing and updating node settings across the shots. This is especially valuable in multi-shot projects where consistency and performance are both top priorities. Recursive evaluation allows a variable to reference another variable within its value, ensuring that all dependencies resolve correctly. This is useful when setting up dynamic paths, shot-specific attributes, or computed values. Now let's go ahead and look at an example. In this case, let's say we're going to be working on 4 shots. So we have these 4 readers. Now let's see what we can do to eliminate 4 readers and just use 1. So first, let's examine the variables we have set up. So we have the show name, but this is not going to be important in this case. What is the show root, where we want to navigate on disk, and the CG root, and this is where the renders live. We have the sequence name, which is a part of the file name, as well as the version. Then we have the shots, and that is a list. And then we have variable sets. So within these variable sets, all we're listing here is the start and end frame for those shots, and that's exactly what lives on disk is these frames. One thing to note is I've named the variable sets just shot S00, whatever the number is, _ source. So now I'm going to copy the path to where this lives on disk, and I'm going to grab a text node and paste it in. We're going to use this just so we can see visually what's happening. So we can see that we have the full path. Next thing we're going to do is we want to create a new variable under our root. And we will call this cgread. Now in the text node, we're going to call on that variable so we can see what happens as we begin to build this out. Now we can begin to build the value for cgread. So the first thing we want to do is call on the variable showRoot. Now when we do that, we can see that our text is built and we have a matching path up to the word script. And that is because now we need to get in the cgroot. So we'll do percentage cgroot, and then now we're up to source /3D. So we're now in the 3D folder. Now at this point, we have separate folder names for each one of the renders, and we can assemble this. And this time it's a dynamic because this is going to change whenever we change our shot value. So first we're going to go / to get into that folder. And then we're going to talk to sequence name. Because this is separated with an underscore, we want to make sure that we have sequence name in curly brackets, and then we'll do underscore %shot. So now note when we change the shot context, watch the text, it gets updated. So all is working well so far. Now we have the file that we want to bring in. So we'll go ahead and again separate it with the /. We're going to talk to sequence name, and then we'll separate that with an underscore. And then we also want to make sure we're talking to shot. And because there's another underscore, we want to make sure shot has curly brackets. And then also version. And we know that version we have set as our value as v1. And just to make sure all is working well, that looks good. And we can do that as we switch. We see that's changing. So let's just add the frame padding at this point. Great. So now we have matching paths and we've built our cgread value. Now we don't need those additional read nodes. We're just going to grab that original one. And this time, instead of a path for the file, we're going to call on the variable cgread. Now that means we have our one read node, and when we switch the shot value, it's switching the path, and then we're able to just use one read node for this. Now, one thing to note here, when we switch to shot 9, we'll see an error. Now, why are we seeing this error? Well, let's have a look. And that is because we don't have frames for that entire sequence. Our read node is set to from frame 1 to 120, but if we look at the actual footage for shot 9, we can see that there's only frames 40 to 90 for this. And that's why we're getting that error. No problem. So our read node thinks, hey, our frame range is from 1 to 20, but you only have frames 40 to 90. So now we have defined the actual frame start and frame end within those variable sets, and we can use this to our advantage here. So now what we can do is select our read node. We're going to add an expression to the frame range. Now in this case, we want to talk to the variable set. So as we build that out, we're going to be doing percentage curly brackets shot. And remember how we named the variable set. So it is called shot S007, which we know is a dynamic number, underscore source. So in this case, we are setting up our expression to be percentage with curly brackets shot, percentage, and then shot. That is the name of the variable set, as well as underscore source. And the variable we want to talk to is called frame start. Great. And now we want to do the same thing for the frame range on the frame end. So we'll go ahead and add another expression. This same thing, except this time we want to talk to the variable called frame end. So now once we do that, and you'll notice we have our single loader and we're switching shots. This time we're not getting an error because we have the frame range defined in our variable sets. So when we switch, not only that, we can see the input changing as we have the viewer set to input, and we're getting the time slider adjusting as well as the shot changing. So that's an example of using recursive evaluation of variables. Now you can call on any of these variables. So we saw how we were able to resolve an entire path by speaking to one variable that was using recursive evaluation of variables. Of course, we could just swap out pieces of the path. So in other words, if we just talk to the show root, because we know that defines up to the word source, then it will also resolve the path. And we could take it further as we have the source root and then the cg root as well. So remember, the benefits of this is that it simplifies project-wide updates. You can modify a single top-level variable and all dependent values update automatically. It also helps reduce errors and eliminates the need to manually update every path when you're working across multiple shots. And it supports dynamic templates, which gives you more flexible, reusable multi-shot workflows. Previously, we explored how expressions can be used alongside variables. Now let's look at another scenario where expressions may be useful within a multi-shot workflow. While many tasks can be handled without expressions, there are cases where they become necessary due to workflow constraints or personal preference. Let's explore a few examples where expressions can enhance control and efficiency. Now, in many cases, we may want to enable or disable resource-intensive nodes based on the stage of compositing. For example, effects such as defocus, motion blur, or lens distortion can be computationally expensive. We might prefer to keep them disabled while building the comp, and then only enable them when finalizing the shot. So let's create a new variable called high quality defocus, or HQ defocus. Let's set it as a list with two string values, on and off. Now in the Bokeh's node properties, which we're going to use for our final render defocus, let's go to the node tab and add an expression to the disable property. So we're going to add a string compare, and the list value we want to talk to is called on. And the variable we want to speak to is HQ defocus. So now when HQ defocus is set to off, the node disables. And when it's set to on, it enables. So now we want to apply the opposite effect to the low quality defocus. And in this case, we'll use a blur node as it's the lightweight version of the defocus. And we'll add an expression to the disable property. So this time we're going to use the same expression, except we want to talk to the off value in the list. So now when the HQ defocus is switched, the high quality node enables, while the low quality node disables, and vice versa. This setup allows us to dynamically toggle between preview and final quality effects using a single variable, making it an excellent candidate for the variable panel. So let's go ahead and push it over there. We can extend this technique to enable a node based on shot selection. For example, if we want the node to be enabled for only shot 7 and 8, we can modify the expression. When switching to shot 7 or 8, the node enables. For all other shots, the node remains disabled. While expressions provide flexibility, they can add processing overhead, especially in complex scripts. So whenever possible, it's preferable to use the variable switches instead. Variable switch node allows you to drive switching logic based on the graph scope variables without relying on expressions. So matching the patterns within the variable panel make the script more efficient and performant. Using expressions can be powerful in certain cases, but optimizing scripts by leveraging variable switches whenever possible will lead to a better performance and more maintainable workflows. The command line interface has been extended to include support for specifying graph scope variables, allowing scripts to be rendered using the correct shot context. This ensures that renders dynamically adapt to different shots and sequences without requiring manual adjustments in the Nuke script. To specify graph scope variables when rendering from the command line, you can use the following syntax with the name and the value of the variable. If you need to specify multiple graph scope variables, separate them with a comma. For sequences, you can use variables in your write node paths, such as this. And then you can execute the render command with specific sequence and shot values. So with this, you can have automated context switching, no need to manually edit scripts for different shots. It's scalable rendering because it supports multiple variables for batch rendering, and you have flexible output paths. So you can have dynamic pathing based on variables that simplifies organization. Using graph scope variables in the command line streamlines rendering workflows, making it easy to automate multi-shot processing with precision and efficiency. Python can be used to automate the creation of graph scope variables and variable sets, streamlining the process setup in Nuke. This ensures that predefined variables, sets, and configurations are established efficiently without manual input. By leveraging Python, users can automatically create and organize variables within structured sets, define variables as lists to provide selectable options for shot names, sequences, or other contextual data, and also ensuring key variables appear in the variables panel by automating visibility settings. Additionally, labels and tooltips can be customized to provide meaningful descriptions and guidance, enhancing accessibility and usability. In this example script, all necessary variables can be defined, and it saves time by reducing repetitive manual configuration. It ensures consistency across multiple scripts and establishes standardized naming conventions across projects. By integrating these automated processes, artists can work with pre-configured, optimized setups right from the start, significantly improving workflow efficiency in multi-shot projects. The following examples demonstrate how multi-shot workflows can be implemented into Nuke, providing a flexible and scalable approach to managing multiple shots within a single Nuke script. This is not a rigid system, but rather a framework designed to adapt how artists already work. Users can continue to lay out their node graph and workflows in a way that suits their needs, with multi-shot seamlessly integrating into existing practices. Whether working with templated structures or custom shot setups, this system is built to accommodate different workflows, allowing artists to stay efficient while maintaining creative control. Perhaps you prefer to work with all nodes exposed at the root level without using any groups and having all nodes visible. In this case, everything that's contributing to the backgrounds are set up on the right of the tree. Everything contributing to the hero element of one of the shots is located in the center of the tree. And then the hero for the next shot is then located at the left side of the tree. In this example, everything is grouped at the root level. This setup is utilizing groups for each element and the group view for quick editing. This example uses a bit of everything: variable switches templated throughout the script, expressions linked to variables, groups and LiveGroups for matte paintings. This example for 4 similar shots is set up in sections, utilizing all the multi-shot components, with a nicely laid out variable panel for the artist. This is a product viz example, so whether it's for shoes, furnitures, cars, or anything else, if you're dealing with multiple variations, you'll be able to take advantage of the graph scope variables. This is just the beginning of MultiShot Nuke. There's ambitious plans for expanding its capabilities and will continue to refine and improve with its new features based on user feedback. The goal is to evolve MultiShot into an even more powerful tool, incorporating additional functionality that enhances flexibility and efficiency in compositing workflows. As artists engage with this system, their insights will help shape the future of MultiShot, ensuring that it grows to meet the evolving demands of modern production pipelines.